Welcome back to Pocket Run. Hey, where are you going? It's just math. Don't run away. Hey. Oh, well.
Alright, we're looking at page 6B, 7 through 9. When we arrived at the race, Lori was 5 meters behind her opponent, then she gained 2 meters every second thereafter. Here are the key words. When we arrived at the race, Lori was 5 meters behind. Behind is a key word. Then she gained 2 meters every second. These words every, each, per, those are key words. She was behind. She started out behind. If she started out behind, that is a negative number. That 5 meters is a negative number because she was behind. She gained 2 meters every second. Alright, so now we're going to fill out our table again. We want to find out how far along the race was she every second. So we're just going to start out with 0. How far was she at 0 seconds? Then how far was she at 1 second, 2 seconds, 3 seconds? I'm just picking those. I could pick 10 seconds if I want. So I'm always going to start out with the easiest numbers of 0, 1, 2, and 3. So at 0 seconds, how far along was she in the race? Well, she went 2 seconds she went 2 meters every second. So 2 meters every second, we've gone 0 seconds. So 2 meters every second, 2 times the number of seconds. And then you're going to add, in this case you're actually subtracting the fact that she was 5 meters behind. That subtraction is important. Okay, this shows what she was originally behind. 2 times 0 is 0, 0 minus 5 is negative 5. These numbers here are what we're going to be concerned with because we're going to use this number in our seconds and then this number to make our coordinates. Now let's go to 1 second. Okay, she gained 2 meters every second. So 2 meters times our 1 second minus the 5 she was originally behind. So 2 meters every second, she went 1 second. 2 times 1 is 2. 2 minus 5 is negative 3. Now she went 2 seconds. She did 2 meters every second, so 2 times 2 minus the 5 she was originally behind. 2 times 2 is 4. 4 minus 5 is negative 1. This negative 1 tells us she's still behind. Then she went 3 seconds. So she goes 2 meters every second. So 2 meters times the 3 seconds minus the 5 she's originally behind. 2 times 3 is 6. 6 minus 5 is a positive 1. She's now in the positive meters. So now let's put all this into a coordinate. At 0 seconds, she was behind 5 meters. This is our x coordinate, this is our y coordinate. Then at 1 second, she was negative 3. This is our xy coordinate. Remember, you do x coordinate first, then your y coordinate. Then the next coordinate would be 2, negative 1. Then your next coordinate is 3, 1. Okay, now we can graph these. Your x value is 0, your x coordinate is 0, and then your y coordinate was negative 5, so it means go down 5. 1, 2, 3, 4, 5. That's right there. Then to do 1, negative 3. Start at the origin, go over 1, go down 3. 1, 2, 3. That's that point right there. Then you can do 2, negative 1, positive 2. So start at the origin, positive 2, down negative 1. Then you can do 3, 1. Go over positive 3, 1, 2, 3. Now we go up 1, positive 1. And then this is our line that we can draw. Always draw your lines, draw them through all your points with an arrow at each end, because this line, those arrows say that it goes forever in each direction. Now to write an equation, how did we calculate her meters? We said that meters equals 2 meters times every second, that's an S, 2 meters times every second she went minus the 5 she was originally behind. So this is how we calculated her meters. Okay, this is page 6B. We're going to do problems 10 through 12, and in this lesson you are learning how to graph word problems and graph an equation. Here we have an equation of y equals 3x minus 4, and it says use this information to fill in the table. So here you can make an XY chart for your XY coordinate system for your graph. You can just pick here is the best way to do this. You pick values for x, then take those values and put them in here to your equation to calculate y. You can pick any values you want for x. In my opinion, the simplest values to pick is always 0, 1, 2, 3. You can pick negative numbers if you want to. Okay? I will do one negative number just to show you, how it works. So first I'm going to pick 0, then I'm going to use 1, and then I'm going to use 2, then I will use negative 1. I should have wrote my parentheses out there. Okay? Negative 1. Okay? So what I'm going to do, and this is just arbitrary, you can pick whatever numbers you want. So basically I'm going to take 0 and I'm going to substitute it right here for x. So basically this would be saying, when I put in 0 right here, I am saying 3 times 0 minus 4. Okay? Y equals 3 times 0 minus 4. Well, 3 times 0 is just 0, and 0 minus 4 is negative 4. So this equals negative 4. So when I put in 0 for x, my y value is negative 4. Okay, the 0 and the negative 4 are the numbers I am going to use. I am going to be paying attention to these numbers down over here. Now let's put in 1. I'm going to put in 1 for x. So when I put in 1 for x, remember this means 3 times x. So putting in 1 means 3 times 1 minus 4. 3 times 1 is 3, and 3 minus 4. I have 3, I get into debt 4, I am in debt negative 1. So when I put in 1 for x, my y value comes out to be negative 1. Now I'm going to put in 2 for x. Putting in 2, 3 times 2. 3 times 2 is 6. 6 minus 4 equals a positive 2. If you want to write it out, it would be 3 times 2 minus 4. And that equals a positive 2. Now let's put in negative 1. Putting in a negative 1 for x. 3 times negative 1. 3 times negative 1. 3 times negative 1. A positive times a negative is a negative. So that would be negative 3. So that's negative 3 minus 4. It would look like this. Negative 3 minus 4. I'm in debt 3. I get in debt more 4. So I'm in debt 7. So basically what I have done is I've created these coordinates. Okay, so I'm going to rewrite them right over here, under here. So I've created the coordinates of 0, negative 4. 0, negative 4. That's my xy coordinate. Then my next one was 1, negative 1. 1, negative 1. Then my next one was 2, 2. 2, 2. Remember I write my x first, then y. Then this one was negative 1, negative 7. Negative 1, negative 7. Now I've got a set of coordinates and I'm going to go plot them. 0, negative 4. Remember x first. I'm at 0. Now go negative 4 in the y direction. 1, 2, 3, 4. So that point goes right there. Now 1, negative 1. Go positive 1 x, down negative 1. That would be right there. Now I'm going to plot 2, 2. In the x direction, positive 2. In the y direction, 2. Okay, now this negative 1, negative 7. Negative 1 in the x direction means to the left. Down 7. 1, 2, 3, 4, 5, 6, 7. Will be off the grid, but somewhere right there. Basically, your points should be in a line. This one's a little off. That should be about right there. So I recommend getting a straight edge and connecting all these. I don't have a straight edge on me, so I'm going to use my piece of paper right here that I have. Line these all up with my points, and then you can draw a line connecting your points. And your points should form a straight line. Then number 12 says write a word problem that fits the graph. Okay, basically with this equation, this number here represents what you are starting with. This number here means you're making, like, let's just say $3 every hour. 3 times x, $3 times every hour I work. So let's just say I started out with $4 in debt. So since I'm in debt, I went to work and I made $3 an hour. So I can figure out if yeah, my X represents my dollars, my hours. If I work 3 times, if this represents I work 0 hours, 1 hour, 2 hour, this is kind of hard to not work any hours. So this represents how many hours I work, and Y represents how much money I made. So I can say I started off in debt $4, and I'm going to get $3 every hour that I'm working. After 2 hours that I work, I see that I am now positive $2. When I only work 1 hour, if my X equals 1, I only work 1 hour. $3 times 1 hour is $3, but I'm still in debt 4, so I'm still in debt -1. So that is an example of a word problem that I'm in debt $4, so I go work making $3 an hour, and then I can use this equation to see how much money, the Y represents how much money am I going to make after so many hours. Okay, I am on page 6A, and I'm doing 7 through 9. We have this word problem. Bill had 1 steak barbecued for the picnic. As the guests arrived, Bill began to barbecue 4 steaks each hour. Fill in the blanks. Okay? Let me point out some key words. This is a key word. He had 1 steak. He started out with 1 steak. Okay? And then he barbecued 4 steaks each hour. This each is very important. Okay? 4 steaks each hour. So then we want to find out how many steaks does he have after 1 hour, after 2 hours, after 3 hours. So for these numbers, you can just pick whatever you want. I always recommend starting out with 0. So we can find out how many steaks he had 0 hours before he ever began. The word problem actually already tells us that. Then we can find out how many steaks he had after 1 hour, 2 hours, and then 3 hours. Okay? So what we can do is we say, okay, he started out with 1 steak, so we know we're going to add 1 steak every time. Then the problem also tells us he did 4 steaks each hour. So we can take the number of hours, so we can take 4, he did 4 steaks each hour. 4 times the number of hours we worked, right here we worked 0, so there'd be 4 times 0 plus the 1 steak he already started with. So he made 4 steaks times the number of hours that we worked, and then we added the 1 steak he started with. So 4 times 0 is 0, and 0 plus 1 equals 1. We're going to focus on these numbers that we get over off to the side because we're going to create a coordinate. Okay, now after 1 hour, how many steaks do we have? Well, he makes 4 steaks every hour. We made 4 steaks times the 1 hour we worked plus the 1 steak he started with. 4 times 1 is 4, plus 1 is 5. So after the first hour, we have 5 steaks. Now, the second hour, we take 4 steaks. He can make 4 steaks every hour. 4 times 2 hours we worked, plus the 1 he started with. 4 times 2 is 8. 8 plus 1 is 9. So we now have 9 steaks after 2 hours. 3 hours. He makes 4 steaks every hour. 4 times the 3 hours we worked, plus the 1 steak he started with. 4 times 3 is 12, plus our 1 is 13. So you see a pattern here. You always have your however many steaks he can make in an hour, 4. This number here, 0, 1, 2, 3, is this the number from this column. Then we added this number that he started with. So this 4 number never changed, and this 1 number never changed, because this is 4 steaks every hour he makes. This is the 1 steak he started with. So this number here is like our X coordinate. If you want to write over on your graph, this is like your hours, and this is like your steaks. So we can create coordinates. So with this we have 0, 1. Okay, this is like our XY coordinate. Then this one we have 1, 5. 1, 5. Then we have 2 and 9. This is like our X coordinate, Y coordinate. 2, 9. Then 3, 13. So we can rewrite the numbers from our chart into coordinates. Now you can take these and go graph them on your graph. Remember, these are XY coordinates. start at the origin, x coordinate 0, now go up 1. This one, go in the x direction of positive 1, starting at the origin, go positive 1, then you go in the y direction, positive 5. 1, 2, 3, 4, 5. You can tell this one's going to be off the graph, because if you go over 2 and then up 9, you're going to be off the graph. You only need 2 points to draw a line. You have 2 points, you can get a straight edge and then draw your line in between your points like that. So that is our line for this. The reason this is important is because then we can figure out how many steaks. Let's just say we want to know how many steaks he made. What if he had a business doing this? And he wanted to know how many steaks can he make after 24 hours. So, you know, you can go through all the numbers, or you can just go down here and say, okay, 24. You don't have to go through all the numbers. You can say, I know he makes 4 steaks every hour times 24 plus the one he originally started with. You can choose any number of hours you want. You can figure out how many steaks he's going to make. This model is used in businesses so they can determine how much product they can make to get out to sell to the customers. Okay, number 9 says we want to write an equation for the line. So you take this information from the graph and you say, how did we get the number of steaks? We got the number of steaks. I'm going to use S for steaks. This is how we calculated steaks. Steaks equal 4, we took 4 times the number of hour we worked plus the original one he started with. So this is the equation that matches this table. Our steaks equal 4 times our hours we worked plus the original steak, the one steak he started with.